There we go. All right, now we're recording. So we are working on graphs of sine and cosine today. These are big. Sine and cosine graphs are very quickly, easily recognizable when you see them. You have to know them, you have to understand them. They are rather unique in what you get. Okay? They are extremely similar. In fact, the sine and cosine graphs are the exact same graphs with one shifted. Okay, one's shifted over. But if you do a phase shift on one, you'll actually have the two of them line up exactly one on top of another. But if you think about the unit circle, and the unit circle once again will be helpful in understanding how to graph the points on this. Okay. All the points on the unit circle for sine and cosine, they all match up in one way or another. They're all very close. They all match up in one way or another. Now, the sine graph, and just to give you an idea of what it is, what is the largest possible value of sine? It's 1. What's the biggest number you have when you go around the unit circle for all your y values? What's the biggest number you have? You have 1. What's the smallest possible value? -1. So your sine graph fluctuates between 1 and -1. And remember, as you rotate around the unit circle, what happens? Every single y-coordinate ends up just repeating itself. No matter how many times you go around in either direction, you'll never have a value larger than 1. You'll never get a value smaller than -1. And it just goes back and forth between those 2 points. That's what a sine graph does. And cosine does the same thing. They just go back and forth between the 2. Now the sine, for me, is easy to remember where it starts at, because the sine of 0 is 0. The sine of very small angles is essentially 0. The sine of a very small angle is essentially the same as the angle measurement. So the sine of 0 is 0. I remember that one very easily. So the sine is the one that goes through the origin. Okay? And then if we plot the points out, and we go out, so we have a maximum of 1, a minimum of -1, and we go from pi over 2, count by pi over 2s, pi over 2, pi, 3 pi over 2, to 2 pi. And if we go ahead and count backwards, we have -pi over 2, -pi, -3 pi over 2, and I know it's hard to read this, sorry about that, and -2 pi. Okay, this is what we want to have for our y-coordinates for your basic pi graph. And those will adjust as we go through, and you'll see the adjustments as we go along. So it fluctuates going up and down, and if you have your unit circle in front of you, know where your 0s and your 1s are, and you can plot the points you need to get the graph. The sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, sine of 2 pi is 0, and if we go backwards the other way, the sine of -pi over 2 is -1, sine of pi, -pi is 0, -3 pi over 2 is 1, and the sine of -2 pi is 0. And you can get those points just through the 4 corners, per se, of your unit circle. I know circles don't have corners. And this is what your graph looks like. That's what a sine graph looks like. And it keeps repeating the same thing over and 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 over. That's what a sine graph looks like. Okay? And it'll keep going, and it'll keep going exactly the same up and down. This is part of the reason why we use sine to describe repeated things. Anything that repeats itself is a perfect application of the sine. If you have anything that repeats itself over and over and over and over and over again, the height off the ground of a Ferris wheel chair. You got the chair going around the circle. how far it is up and off the ground, it just goes like this vertically. If they have something that does the same thing repeatedly, you can match a sine to it. You have a spring that's got a weight hanging off it. You pull on the spring, the weight bounces up and down. How much that string stretches. That fits a sine curve. Your heartbeat. So I talked about your heartbeat's called a sinusoidal rhythm, not because it has anything to do with your nose, but because a sinus rhythm from the sine curve. Anything that repeats itself can be adjusted. And you can change things and tweak things to make it look really funky, but it repeats itself. Okay? And these are called waves. And if you study waves in physics, what do you use to describe waves in physics? Sine functions. Okay? Physical waves, if you are a uber geek, you're standing on the beach of the sunset. Oh, that's pretty. But look at the waves. Then you start looking at the wave. Yeah, done that. Okay. Of course, I do appreciate the beauty of a sunset as well, but I also understand the science behind the sunset and the science behind the waves, the motion of the ocean waves and stuff like that, and why they work. But yeah, light waves described by sine functions. Okay. Like I said, cosine looks almost exactly the same. We have the same points along the x and y axis. Positive 1, my bad. We don't flip it upside down. Go from 1 to negative 1. We have 0, pi over 2, pi, 3 pi over 2, 2 pi, and then the same thing going backwards, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Here's the difference. It doesn't go through the origin. What is the cosine of 0? 1. Where's 0 on the unit circle? It's straight out. What is the x-coordinate on the unit circle when you're going straight out? It's 0. So the cosine, it's 1. So the cosine of 0 is 1. So this one passes through the point here. And then goes down. At pi over 2, the cosine is 0. At pi, the cosine is negative 1. And then I go back up to 0, and then back up to 1. And if I go the other direction, it goes exactly the same thing in the opposite direction. And the cosine curve is the sine curve shifted over. You can take any sine function and rewrite it as a cosine function and vice versa. Now, of the two, the most commonly used one is the sine. But you can take a sine, you can take any function, and I think one of the things we're doing today, we will take a graph and we will write it both as a sine and a cosine. Two equations to describe the same curve. Okay, you can do that. They are exactly the same except for shifted over. Okay, and we can make those adjustments as necessary. Most often they use sine rather than cosine. Yes, ma'am?
How does the pi over 4, like cosine equal negative?
It's not pi over 4, I said pi over 2. Pi over 2. You have to listen, not just watch. It's pi over 2. 3 pi over 2. They're all over 2. Okay? Does that help?
Yeah.
Okay. No, that's fine. It's okay. I know there's not a lot of room, and these pens aren't exactly fine-tipped either. Questions so far? And this is just to get an idea. You will see these types of curves often. There's a lot of things that these work for. This is extremely useful. And having in your head the understanding of sine and cosines, what they look like. Ooh, you see a function, and this is one of those things that I talk often about what you're going to be doing when you get to calculus. This is one of those things where you have to be able to think, I got an equation that's got sine involved. What does that graph look like? Oh, it looks like a wave of some sort. I have an idea, a picture in my head immediately what that looks like. What adjustments can I make to it? We're going to learn about those adjustments today. But being able to, in your mind, oh, it's a sine curve. That means it goes like this, and have an idea what it looks like. Okay? So, domain and range. The domain is everything. All real numbers. We can take the sine or cosine of any angle or any number. And if you think about it, the unit circle, we've already kind of talked about that. So we've had, 0 to 2 pi is our range that we deal with. But remember, we've gone around more than once. And we've also gone in the negative direction more than once. So we can have any value. We can take the sine or cosine of anything. Okay? Absolutely anything. However, our range is limited to between -1 and 1. We will not, straight up sine, get a value larger than 1 or a value smaller than -1. That doesn't mean we can't make adjustments. But when you're just taking the sine, that's what we get. And even once again, if you look at the unit circle, doesn't matter how many times you go around the unit circle, you're never going to get a y value larger than 1 or smaller than -1, and the same thing with your x values. They're never going to be bigger or smaller than -1, bigger than -1 or smaller than -1. Never going to happen. Okay, that's an important thing to remember. Okay. Amplitude. Distance above/below the center of the function. So your standard sine, and I will say sine, although cosine, the same rules apply for cosine. Your standard sine function has an amplitude of 1, meaning it goes 1 above and 1 below. We can make it taller than that. We can make it stretch more. We can make a sine curve that goes from 2 to -2. We can make one that goes from 3 to -3. We will do that. Okay. But your amplitude is the height, how tall it is. And it's not the total height, because our total height is actually 2, but it's the height from the center, which in this case is 1. Our amplitude is 1 because it goes 1 unit above and 1 unit below the center line. Okay. Yes?
So effectively, like if you're to look at the circle, you're making the circle bigger and smaller.
Essentially, along those lines. Okay, we'll talk about how that happens here. Okay, and then we have our period. Okay. So our period is how often it repeats itself. Where does it begin repeating itself? Your standard period for a sine function is 2 pi. Because if I look at this one here, from 0 to 2 pi is 1 cycle, 1 period. Okay? It's 2 pi units long. If I keep going, it's going to take this portion and repeat it, and take this portion and repeat it, take that portion and repeat it over and over again. That section is the one section where the no repeats happen. That length that is repeated over and over again, that is our period. Okay. Questions? By the way, amplitude and period have a lot to do with your radio. AM radio. Anybody listen to AM radio at all anymore? You do? What? Yeah. AM radio. Amplitude modification or modulation. AM radio means that the height of the radio waves are stretched up and down, and that determines what you hear. That's a real simplification of what's going on. FM radio, frequency modulation. Period is also frequency. Now, we don't use frequency in here, but you talk about frequency in physics. Frequency modulation. FM radio, you change the length of the period, but not the height. AM, you change the height, but not the period. In FM, you change the period, but not the height. And it's that fluctuation of the period that changes what you hear when you're listening to FM radio. Now that things are digital, stuff kind of is changing a little bit, but that's how radio works. Because radios are waves. It's radio waves. And you change the waves in order to change what you hear. And that's where it comes from. Yeah. Now, if we are working with the period, and this is probably the part that's going to be the most difficult for you to wrap your head around while we're working on what we're working on today. The standard period is 2 pi, but we may change that. Okay? The sine of omega x, screw it, I'm just going to call it W. It is omega, but that's okay. The sine of wx, W is the number of cycles in 2 pi. This is our modulation. The sign, the number in front of x, inside the parentheses, that's what changes our period. Okay? And it's the number of cycles in that 2 pi. So if we want to change it, rather than having going from 0 to 2 pi, we put some number in front of x. And that will change our period. That will change our frequency. That'll change the length of what we're talking of our wave, of one cycle, one wave. Okay? If it's inside the parentheses. Now, like I said, it has sine, but this is also true for cosine and the other trig functions when we get to them. Okay? Each period, instead of the length of 2 pi, has 2 pi divided by that. So let's say I have sine of 2x. Well, normally the sine has a period of 2 pi, but if I have a sine of 2x, its period will be pi. So instead of so its wavelength will be half as long. It'll cycle from 0 to pi instead of 0 to 2 pi. Okay, it goes twice as fast. The number in front that's larger, it goes that much faster. So it'll be 2 times as fast. And we'll have 2 cycles in what would normally be 1 cycle. Okay, and we'll work on finding that amplitude and period and rewriting those graphs. Okay? Questions? Okay. So we're going to graph these functions. And these are the simplest, most basic sine and cosine functions. Graphs of y equals a sine wx or y equals a cosine wx. The a in front does the amplitude. My amplitude changes according to that value. That is my amplitude. Normally, if I don't have any number in front, what do we have? We have a 1, right? If I have a sine by itself, it has a 1 there. We have 1 sine, right? So our normal amplitude is 1. If we put 3 in front of there, instead of going from -1 to 1, we will go from -3 to 3. Okay, that's what the number in front will do. It'll raise your amplitude up that much. And then the omega part, sorry, the W part, that will tell us what our period adjustment, what our period changes are. Okay, so we're going to go through and graph these functions together. Now I know I have little lines on mine, and I don't have them on yours. My apologies. Next year students will have the lines on theirs for them. Okay. So let's go through and do these. We're going to determine the amp and the period, and then we're going to go from there on how to graph it. So y equals 2 sine x. And we're only going to graph 1 cycle. We're not going to graph a whole bunch. We're going to graph 1 cycle. But if you remember, if you got 1 cycle, what do? You just repeat that one over and over again as needed in either direction. Okay, so you'll notice my graphs start at 0 and go from there. Now we may shift them over at a later date, but we're all going to start at the beginning on these ones here. Okay. So the first question I have is, what is my amplitude on this one? Yeah. My amplitude on this one is 2, which means that my graph goes from 2 to -2. Okay, I go from 2 to -2. What's my period on this one? It would be 1, because do I have sine? I have just sine x, right? If I had sine of something other than just x, that would change my period. So my period on this one, that's nice. This makes it easy. The first one, my period is your good old normal 2 pi. No change. Now, if you look at the directions that are on your thing, it says divide the period by 4 to determine the incremental length. Yes, ma'am.
Wait, so your period is just
Normally it's 2 pi. There's no changes, it's 2 pi. And if I look at my graph here, what do I have? How many x's do I have? I have 1 x, right? So because I have the 1 here, my period doesn't change.
So, but if you see the one down low, where it's
We'll get to that. We will get to those. Yeah. It'll be changed on all the rest of them, just not on this first one. Okay?
Yes.
So our period is 2 pi. So here's what we want to do to graph it, to make it easy to graph. We go down, put what our period is. In this case, it's 2 pi. So we're going to go from 0 to 2 pi. Divide that. So you have 4 equal parts. Okay. Now, if I want to go from 0 to 2 pi, what am I going to be counting by? I'm going to be counting by half pi. And what you want to do to be able to get the increment, to know what these numbers are you're counting by, what you do is you take your period, whatever your period is, in this case it's 2 pi, divide it by 4, you get pi over 2, and that means I'm going pi over 2, and then pi, and then 3 pi over 2. And then I graph it. Where does my sine begin? At 0. My sine begins at 0. It's important to remember which one begins where. So my sine begins at 0, goes up to, normally how high up would it go? Well, in this case, so it's going to go up to 2 because it's twice as tall. And then it goes back down to 0 at pi, and then down to -2, and then back up to 0 again. And it looks like that. There you go.
You not put arrows on it? Just ends.
You can put arrows on it if you want to indicate that it goes on. I'm only asking for 1 cycle, so it really doesn't matter at this point. So far so good. Okay, so the next one. Ooh, the next one's a little tricky. First thing, the easy one, is our amplitude. What is our amplitude on this one? No. Our amplitude is 3. However, the negative is important. What does a negative do?
Flips it.
Flips it. So this would be a reflection. So when we go to plot the points, that will be an important thing to remember. But the negative actually does not affect the amplitude. Our amplitude is the absolute value what's in front. The negative just takes the whole thing and flips it over. And you'll see that here in a minute. So now we need to find our period on this one. And to find our period, we take 2 pi and divide it by by how many ever x's we have. In this case, we divide it by 2, which means our period is pi. Okay. So what do? We go from 0 to pi and divide that into 4 equal portions. So this would be pi over 2 in the middle and pi over 4 here and 3 pi over 4 here. Now it's important to remember that we are not going to have the same values for the cosine that we would have at pi over 4. Because technically what are we doing at pi over 4? We're putting pi over 4 into here and we're having 2 times pi over 4. Right? So that's normally where we would be at. Normally, the cosine of pi over 4 is root 2 over 2. But remember, we're going to have 2 times pi over 4. Take the cosine of that number. That's what we're doing there. Because remember, this is implied at this point that we have the parentheses there. So, what's our amplitude? It goes, okay. Normally, where does the cosine start?
1.
At 1. Normally, cosine would start at 1. But because we have an amplitude of 3, it would start at 3. But the negative means we start at negative 3. So it's really actually not that hard. You find the starting point, and then you're going to either go up or down as appropriate. In this case, we're going to go up because we're starting at the bottom. Pass through the x-axis. Same side above. Pass through the x-axis, and then come back down here. So it's going to look something like that.
Why do you keep going up? You have to go through it and then come back out?
Yeah. Well, you have to go up to it and come back down. And if you look closely at sine and cosine graphs, they almost flatten out. I mean, technically, you zoom in on a curve, what do you get? You get a flat line no matter how close you zoom, no matter how sharp it is, you will get flat. But the cosine and the sine tend to go up steep in the middle and then kind of slow and then kind of come down steep and then kind of shallow out at the bottom. It's really kind of funky the way they do. This is as good as I can do by hand and as good as I would expect from anybody. Okay. You'll notice at the bottom it looks like I actually kind of go flat into the point. That's often how you will see in textbooks and such, where it's a cosine where it ends or sine where it ends like that. It kind of looks like it flattens out into that point. Okay. Because it kind of does. It's hard to do by hand. Okay. So let's take a look at the next one. What's our amplitude? Our amplitude is 1. Oh, I like those. Amplitudes of 1 are nice. But we do also have a negative, so we got to watch that. Okay. What is our period? And this one's a little bit harder. We have 2 pi divided by pi over 2. Simplifies down into 4. Yeah. So this one actually doesn't have, it's not very often that you have a period that does not have pi involved in the period at some point, but it does happen. So this actually makes it easier to do the numbers at the bottom, because what am I going to count to? 1, 2, 3, 4. So you go 0, 1, 2, 3, 4. And our amplitude is 1, so that makes it easy. 1 to negative 1. And where do we start with this sign? We start at the origin. And normally, which direction would we go? But because we have a negative, which direction are we going to go? We're going to go down. So you start at 0, go down to negative 1, back up to 0, up to 1, back to 0. And it goes like this. Okay, cool. Yeah, sine and cosine are they're extremely common. They're very versatile. They're not that hard to draw once you start breaking down the parts. So I did the first 3 easy ones. Try to do these 2 harder ones. So the first one here, our amplitude is 5 halves. We have 5 halves and negative 5 halves. That's not too bad. Period's not that difficult on this one either, but it's not great. So our period on this one is 2 pi divided by 1/3, which is 6 pi. Okay. So we go from 0 to 6 pi, and we have to divide that evenly. Well, the middle part's, that's nice. That's 3 pi, because half of 6 pi is 3 pi. Okay, and half of 3 pi is 3 pi over 2. And the one between these two are a little bit more difficult, but that ends up being 9 pi over 2. Okay. Where do I start? I start at the top, because cosine it normally starts at 1, so we're going to start up here. Okay. Yes?
If you were to find those 4 values, I mean,
Yeah. Divide that by 4, and that tells you how to count by. Does that make sense? Yeah, if I take 6 pi and divide it by 4, what do I get? 3 pi over 2. So I'm counting by 3 pi's over 2. It's however way you want to do it. There's plenty of ways. So I start up here, go down to 0, go down to -5/2, back up to 0, back up to 5/2, and it goes down and then up. Like that. Kind of like an upside down normal distribution curve. Questions? So the next one, what's my amplitude on the next one? My amplitude on the next one's 1. Ooh, that's nice. So my amplitude is 1. So I go from +1 to -1. And then my period is 2 pi divided by 3/2, which ends up being, what did I have down here? 4 pi over 3. Four pi over 3 is what I get. So what do? I count by pi over 3s, because if I have 4 of them, divided up into 4 equal lengths, I get pi over 3, 2 pi over 3, and then 3 pi over 3, which is pi. Right? 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. 1, 2, 3, 4. And then I plot my points. Where do I begin? At the origin, 0, 0. Which way do I go? Up or down? I go up. Where do these stairs go? They go up. How many of you got that joke? Oops, this is where it goes. There you go, I was off. My bad. Right? Where do these stairs go? They go up. Ghostbusters. The first one. It's full of little lines like that I just love. Listen, do you smell something? I mean, it's got lines like that throughout the whole movie, but yeah, that's one of my favorites. Questions on this? Okay, now we're going to reverse engineer, and we're going to find the equation from the graph. So we need to determine our W and our amplitude, and decide whether we have sine or cosine. So let's start with the easy one first. What's our amplitude? 2. Our amplitude is 2. Okay. Now let's find the more difficult one. Find our W. So what's our period? Our period on this is 4, because that's where we get one full cycle is 4. So our period is 4. But what is our period equal to? Our period is equal to 2 pi divided by W. We got to figure out what W is. Cross multiply and solve. Swap the 2, so we end up getting W is pi over 2. So that's what we're going to have in front of our X. So I've got a good start. I know my amplitude is 2. Does this one begin, where does this one begin at? It begins at the origin, right? Which means it's going to be a what? A sine. So we have 2 sine of pi over 2x. However, it's negative because normally what does it do? It normally goes up, but this one's going down. So I do have to make it negative because this one is going down on here. Normally, what does it do? Normally, the sign starts by going up, not by going down. Okay. Yes?
Does it make any difference, like where it says sine pi over 2x, does it make any difference if the x is inside or outside?
Generally speaking, we put the x outside. We put this pi over 2x next to it, not inside the fraction by convention. Does it really matter? What?
Like it's at the front.
It needs to be inside the parentheses because that means we're taking the sign of pi over 2x. Because if we have the pi over 2 in parentheses and the x outside, then we're taking the sine of pi over 2 times x. Does that make sense? And I like to do the parentheses because I like to know for sure what I'm taking the sign of and what I'm not. If it's in parentheses, I'm taking the sign of that number. If it's not the parentheses, I'm not. Okay? So what's my amplitude on this one? 3/4. And my period,
Oh yeah, 'cause this is
so what is that distance? And that's you got to kind of figure it out. Well, this goes from 0 to pi. How many divisions we have? 1, 2, 3, 4, 5, 6. So these count by pi over 6s. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which reduces to 2 pi over 3. So our period is 2 pi over 3, right? Because 4 pi over 6 reduces to 2 pi over 3. And that's going to be equal to 2 pi over W. So what's our W? W is 3.
Why would it be too hard? Why would you put a point like where?
Because where does it stop repeating itself? Remember, it repeats itself. This is not the end of where the repeat is. It goes from here to here. That's the distance of one period. Not to the end of the graph. Because it didn't go to the end of the graph on the first one either, did it? It's not to the end of the graph. It's one period length, one cycle. One cycle, when it starts repeating itself, you're into the next part. So one period is one cycle. Okay? Does that make sense? So our W is 3. That makes that nice. And then are we going to do sine or cosine on this one? We're going to do cosine on this one. And does it need to be negative or positive? It's positive because it's doing the normal cosine thing. Y equals 3/4 cosine of 3x. Yes, ma'am.
Sorry, I had to follow how you got the period for that.
Okay, so what's our period length? Our period length is 2 pi over 3 because what do? It's from where it starts to where it ends, right? And these, because that's a pi there, each one of these ticks is pi over 6. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which is what? Reduces to 4 pi over 6 reduces to 2 pi over 3. Set that equal to 2 pi over W, and you get to find your W, which is your period adjustment. Okay. Ooh, now we get into some more fun. So we have not, we've had an adjustment of how tall or short it is. We've done our AM, we've done our FM. Now we're going to make some other shifts. Vertical shifts and phase shifts. Vertical shift is just like a vertical shift on, let's say, a parabola. Right? You wanted to move a parabola up or down. What did you do? You added a number outside of the square. X squared plus 1 is x squared moved up 1. X squared minus 5 is x squared moved down 5. This is the same thing. If we have something plus or minus that is not part of the trig function, it takes the whole graph and moves it up or down. So our amplitude will maintain the same, but not necessarily be centered upon the x-axis. It will be centered upon whatever we move it up or down. Okay, so that's a vertical shift. You add some number outside. It moves the whole graph up or down, just like before. Okay, and then we have a phase shift. A phase shift is a trig way of saying a horizontal shift. Moving the whole graph, left or right. This is how a phase shift is how you make a sine graph look like a cosine graph. You phase shift it over until they line up on top of each other. That's why every sine and every cosine can be written as the other one. Because all you have to do is add a phase shift in there, and you can just move the whole thing one way or the other, whatever is necessary. Okay. That's why almost all of your functions, if you write a function for using trig functions for repeated, they're almost always sine equations. Because they just go straight for the sine rather than the cosine. For some reason, that's the most common, but you could use them interchangeably technically. But sines are where everybody starts with. That's the most common one you use. Okay. Now, this is probably the hardest part that we're going to have to figure out here today. To figure out the horizontal shift. Okay. What you need to do is you need to factor out the period change. You need to factor that out. Because what we're looking at is we're not looking at something of a period of 3, our adjustment is 3, and then we do this to it. Remember, it's the whole thing that is adjusted that way. That's what we need to do here. Okay? So we have vertical shifts and phase shifts and all kinds of crap going on here. Okay? So let's work on trying to figure these out. We're not going to graph them right away. Right, first thing we're going to do is just figure them out. So to go back to what we were doing, our amplitude would be what? Our amplitude would be 4. Our period, phase shift, and vertical shifts. The vertical shift is actually easy to get to. We'll do that last. Your period and your phase shift are tied together. Okay? Now, what is the W for the one that we have here now? What do we have in front of the X? 3. So that can give us our period. We know that our W is 3. We know that. Whatever we have in front of X, that's our W that does our period change. So our period, remember, is 2 pi divided by whatever W is. So our period in this one is 2 pi over 3. Our phase shift is not pi over 6. Our phase shift is not pi over 6. Because the phase shift is part of the period shift. Okay, so what we need to do is we need to take this and factor it out of the whole thing. So we have to factor the 3 out. So we have 3 times x minus whatever. So we have to factor 3 out of pi over 6. Does that make sense? Okay. It's not easy to do with fractions. However, sometimes it's easier to think the other way around. Okay, 3 times what is going to give me pi over 6? That would be 3 times pi over 18. Right? Because 3 over 18 does what? Reduces. So you're pulling that out. Okay, does that make sense? So what is our phase shift on this? Our phase shift is pi over 18. No, because it's minus. Isn't it minus? Yeah, it's minus. It has plus there, but it's actually minus whatever it is. Because remember back to your quadratics. And when we move our quadratics left or right, they moved in the opposite direction. Remember when you had x minus 1 squared? Ooh, that means we moved to the plus 1 direction. When we had x plus 5 squared, we moved it into the negative 5 direction. Inside parentheses moves it in the opposite direction. Outside parentheses moves it in the same direction. Okay, so if it's minus there, our phase shift is positive. If it's plus in there, because remember, inside, opposite. Always think about that, inside, opposite. What's our vertical shift on this one? 1. Our vertical shift is 1. The whole thing moves up 1. Do we have anything else going on with that one? It's negative. Which means that it would do what? It would have a reflection. So flip the whole graph over. And a negative, by the way, can also be corrected by a phase shift as well. It's really kind of cool. Okay, amplitude. What's our amplitude on this one? 2. Remember, it's the number in front of the cosine. So our amplitude on this one is 2. Our period. How many x's do we have here? We have 1/5 x, right? So our W is 1/5. So our period is, so W is in this case 1/5. So our period is 2 pi divided by 1/5, which is 10 pi. That means you're going to have a sine wave that's really long. Very slow moving sine wave. Very low on the color spectrum. Phase shift. So remember, we're getting a factor of 1/5 out of this. So I have to take this and make it 1/5 x plus something to get pi. Yeah, 5 pi. 1/5 times 5 pi gives me pi. So that means our phase shift is negative 5 pi. Remember, you're going in the opposite direction. So it's going to take the whole graph and move it over negative 5 pi places. And then our vertical shift, that's an easy one. Our vertical shift is what? Negative 3. It's got it in front of the trig function instead of after the trig function on this one. Question? Okay. This is actually easier to do than the other direction we went. Okay? We're doing a trig function. Our amplitude is 2, our period is pi, our phase shift is 1/2. We do not have a vertical shift on this one. So, because it tells us right here in the directions to do the sign. Otherwise you wouldn't know, but you have to be told which one you're going to do. So our amplitude is what? 2. So we have 2 times the sine. What is our period? Pi. Because it tells us right here in the directions. Okay, shh. So our period is pi. To x, what's our phase shift? 1/2. So what do we have? We have minus 1/2. Remember, it's opposites. Now, this is not pretty, so what do? Distribute the pi. Y equals 2 sine of pi x minus pi over 2. Yeah, this is actually, I think, easier than what we just got done doing. Personally. It's doable. Okay. So the next one. Same thing, it's a sine. What's your amplitude? What's your period? What's your phase shift? What's your vertical shift? Plug them all in. Why am I blanking? Yeah, 4.5. 1.5 times 3 is 4. Sorry, I was just blanking on what 1.5 times 3 was. No, leave them like that. If you're giving decimals, do decimals. Don't screw them. If you're giving decimals, leave them as decimals. It's not worth it. Okay, questions? Ooh, I made a mistake.
Oh,
I made a mistake. My bad. What? Did anybody have an idea what I screwed up on?
Is it the phase shift?
Nope. It's not the phase shift.
It's your,
My period is not pi, or my period is pi. That is not what my W is.
oh my gosh. I knew it.
Really? Then why didn't you say something?
wait, on both of them?
Yep.
Let's go.
Oh, yeah.
Oh, come on.
I thought it was asking.
So,
I knew it was you. Who needs an eraser?
that's what we're dealing with. Remember, our period is 2 pi divided by whatever W is. W is what's in our equation. So 2 pi over W equals, well, you don't have to erase it. You should have enough room to write it underneath. Just cross it out. I erased it because it's easier for me to erase it. Okay, my bad, sorry. So 2 pi over W equals what our period is, pi. So I got to figure out what W is. W in this case is 2.
Wait.
Yeah, the pi's cancel. Or the 2's cancel. You put 2 in there, you get pi equals pi. Now we can do this. Everything else is the same. 2 sine of 2 times x minus 1/2, which gives us y equals 2 sine of 2x minus 1. My bad.
Where you set it as 2 pi over W equals pi, that's what you're saying, it's what it says through.
So in this case, it tells me my period is 1.5. I do want to make it fractional for this part here. 1.5 is 3 over 2 is equal to 2 pi over W, and we need to solve for W. Which for this one here, I would cross multiply, and you get 3W equals 4 pi. So W equals 4 pi over 3. So Y equals my amplitude 3 times the sine of 4 pi over 3 times x plus 3, all plus 5. Distribute the 4 pi over 3. Y equals 3 sine of 4 pi over 3x plus 4 pi. All plus 5. My bad. Yeah, but then you would have got it wrong on the test and on your homework. Or I would have caught it. I would have caught it tomorrow, teaching the class tomorrow, and then you guys would have been screwed.
Yes.
I know, long day. Okay, graph 1 slide. But you got a 3-day weekend after this, so don't complain. Yeah, Veterans Day. Okay. So graph 1 cycle of the function. Okay, this is where it gets fun. We need to figure out all the different parts like we did earlier. Our amplitude,
It's 3.
our period, our phase shift, our vertical shift, if we have one. So the first one's actually very easy, our amplitude. Our amplitude is 3. Our period is 2 pi over 3, because what's our W? Our W is 3. We have WX. 2 pi over 3, that's our period. Okay. Our vertical shift, because that's easy to do, is 1. That means the whole graph moves up 1. Okay. Now to get the phase shift, which is probably the most difficult thing to do when we get to graphing it. Okay. Our phase shift, what do we have to do? We have to factor 3 out of this. So we get 3 times x minus pi over 3. So our phase shift is pi over 3, which means the whole graph is going to move over pi over 3. So let's find our increments first. Normally, where would we start? We start at 0 and go to 2/3 pi, right? So we still want to kind of keep that in mind. So we go from 0 to 2/3 pi. 2 pi over 3. But what's our phase shift going to do? Our phase shift is going to move the whole thing over pi over 3. But let's go ahead and divide this up the way we normally would. You divide this in half, you get pi over 3. Divide this one in half, you get pi over 6. Divide this one, you would get 3 pi over 6, 5 pi over 6. Right? No.
That's pi over 6 times 3 is 3 pi over 6, which is the third increment.
Which is pi. Pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2. Thanks. And then we have this. So normally this is where we would be, right? Normally this is where we'd be. But what is our phase shift going to do actually? Our phase shift is going to take this point here and actually move it over to here. That's what our phase shift is doing. It's going to move it from here over to that point there, which means all of these are going to be moved over. So I have to add 2 more slots to make up for these. So instead of ending at 2 pi over 3, it's now going to end 2 more over. So this would be 5 pi over, yeah, let's see. 1, 2, 3, 4, 5 pi over 6. And this would be pi. I'm counting, okay. Pi over 6s is what I'm counting by. And what do? You want to, how do you find that number? Take your period divided by 4. Take 2 pi over 6 divided by 4, 2 pi over 3 divided by 4, and you get pi over 6. Take your period divided by 4 to tell you your increments. Okay. So now we're going to start here instead. So that's our phase shift taken care of. Our amplitude normally would go from -3 to 3, right? But what do we have for a vertical shift? Our vertical shift is 1, so instead of being centered on the x-axis, we're now centered on the line x equals 1, because that's what our vertical phase shift does. It lifts the whole thing up 1. That's what this does here. It lifts the whole thing up 1.
So wait, you're still going up to 3, but now
I'm not going from 3 to 3 to -3 anymore. I'm moving the whole thing up. So I'm going from what to what? I'm going from 4 to -2 now, because I moved the whole thing up 1. So my amplitude, instead of being -3 to 3, I add 1 to both of those and lift the whole thing up. Okay.
We decided it went over to pi. So 2 pi.
Yeah, it goes all the way over out to 2 pi.
But how do we figure that out?
Because that's what our phase shift is. Moves it over one third of a pi. Move it over that spot. Okay? Now, this is the hardest part to do. Once you've figured this out, this is not easy. Where do I put my first point? Normally, for the cosine, where do I normally start for the cosine? Normally, I would start at 1, right?
Yes.
However, with the amplitude, it's going to be moved up to 4. Vertical shift and amplitude being moved up to 4, but the phase shift moves that over to here. That's now where I'm going to start. And then I go down to my center line. And then I go down to the bottom of my amplitude, back up to my center line, and then back up to the top again. And so my cosine looks like,
But like in reality, you would move those numbers up back on top, right?
Yeah.
Okay. So
yes,
How come the max is it there?
it's not 9, it's 4. It's an ugly 4. 4.
How come that? Oh, wait.
Because what's our amplitude normally go up to?
Okay.
3, but we have a vertical shift that moves it up 1. Because what we normally do from the amplitude, we go from -3 to 3, but the phase shift moves the whole thing up 1. Okay, so the next one's actually a little bit easier. Find the 4 things.
Okay.
Amplitude, period, phase shift, whole 9 yards. Bless you. Yeah, this one actually is not that hard. Oh, that's one long video. Once in a while, it's going to go really long like this. Sometimes it's not. I didn't pause it for this blank spot either, so. Okay, what's our amplitude? 1. Yay, that makes it easy. What's our period? Our period is pi because we have 2 pi divided by 2, which is pi. What is our phase shift? Negative pi over 4. And what is our vertical shift? Yeah, we don't have a vertical shift. Yay, that's nice. That makes it easy. So basically what are we doing here? We're moving the whole thing over, pi over 4. And what else are we doing? flipping it because we got the negative. Watch for your negatives. So normally we would go from 0 to 2 pi with pi over 2 and 3 pi over 4 and pi over 2 here.
Wait, you're only going to pi.
Yeah.
Oh, that's right, the period's pi. My bad. Thank you. That actually makes it easier. Pi, so we have pi over 2 and pi over 4 and 3 pi over 4. But what are we doing with our phase shift? We're moving everything over backwards 1 pi over 4. So that means we're starting here and we're ending here.
Wait, you still start at the origin, right?
No, you don't start at the origin. You move it over. Start at where the phase shift takes you to. So sine normally starts at the origin, right? So we're shifting that spot over to here.
And you go down.
And instead of going up, we go down. And here, let's set up the -1 and +1. So we go down to here, up to here, up to here, and down to there. So we go ooh, like that. Doing that roller coaster ride. Okay, questions? That last one actually was easier than the first one. So. Almost done. One more problem. Don't worry, you'll have lots of practice to make sure you get it right. Yes. Huh? What?
For the graph, how do those
Because my phase shift takes me from here to here. So normally I started here, but my phase shift moved it over. So this is my new starting point. Okay? All right. Sine, cosine. We need to write two equations to fit this graph. We need to find a sine and a cosine.
Yes.
First question. Easy question. What's my amplitude?
3.5.
Amplitude's 3.5. Yeah.
No.
Nope.
Then you were there. And then
Not necessarily. Because what does the cosine do? Cosine starts up and goes down. So if we're talking cosine, we have that. And our amplitude's the same. What's our period? And let's do from the top. The period, here's what's nice about finding the period from the graph. It's from any point in its repeated place, next one down. So our period goes from here to there.
yes. Whoa. It's counting by
2 pi over 3. Because halfway is pi over 3, so all the way is 2 pi over 3. So we travel. So hang on. Our period is 2 pi over 3. But remember, we need to figure out to write the equation, we need to know what our W is. And it's 2 pi over W, which means that our W is 3. Because our period is 2 pi over 3. Okay. Now, do we have a vertical shift?
no.
No, because our top and bottoms are the same except for plus and minus. So we do not have a vertical shift.
We don't have phase.
Do we have a phase shift for cosine? No, for cosine, no phase shift.
Wait.
Cosine has no phase shift. So let's go ahead and do the cosine. Let's go ahead and do the cosine because we don't have a phase shift for the cosine. Let's do that. That's easy. Y equals the amplitude, 3.5, times the cosine, cos for this purposes, times our W times x. 3.5 cosine of 3x. It's easy because there's no vertical shift and no phase shift. Figure out your W, figure out the other one. Because normally, where does the cosine start from? Starts from 1. 0, 1 is normally it starts from. Our amplitude just moves that up. Our peak, if our peak is on the y-axis, our cosine has no phase shift. Now, where does the sine normally begin? At the origin. So what we do is we find the first place where the sine crosses the x-axis. That is the beginning of our sine. How far over is this? What's this distance here? Pi over 6. After pi over 3 is pi over 6. So our phase shift for the sine is pi over 6 because our starting point has moved pi over 6 places. Now there's something else very important going on with the sine on this one. Normally, where does the sine, what direction does the sine go? Normally it goes up, so this one goes down. So instead of being plus, it's going to be a minus. Because it goes down for the sine.
Or if you also just make the phase shift negative.
Yeah, you can do the phase shift the other direction and make it positive going up. You can do that. There's a lot of adjustments you could do. Because you don't have the other part of the graph, the implication is you just deal with what you have. So I have one full cycle. It goes from here to here of the sine. So I go with the full cycle that's given to me. So I would do y equals negative 3.5 sine of, what's our period again? Our period was what? 3, because the period's the same for both. 3 times x minus pi over 6. If you wanted to go the other way, you could make it a plus. Only it wouldn't be pi over 6. It'd be, yeah, it's a little harder when you don't see it, but you could go, if you had the whole graph, you could do it that way. Distribute to clean it up. Y equals negative 3.5 sine of 3x minus pi over 2. And thus endeth the marathon session. Okay. Question?
No.
Sure? Okay.